Hello. So in this video I'm going to talk about graphing a pretty complicated secant graph. It's -5 secant of quantity 2x minus pi over 3 quantity plus 6. Now, I'm going to approach it first from the point of view that, hey, this is my last math class. This is pretty specific stuff, so I just kind of need to be able to recognize the graph. So let's go back to what is the basic shape of secant, right? And if you recall, secant is going to have asymptotes, right? Because this is basically r over x, and when x is 0, you have an asymptote, so it's going to be at pi over 2, negative pi over 2, right? So this is coordinates 0, 1, 0, negative 1, so when x is 0, right, you have an asymptote. So you're like, okay, well, I know the basic shapes is that it's an alternating U, it looks like, right? And has asymptotes at pi over 2 and all multiples thereof. So here at 3 pi over 2, that kind of thing, 5 pi over 2, 7 pi over 2. And I know that this is the cosine, right? It's coming up here. So this is going to ride the cosine wave, where the cosine would be here, right? And so on and so forth, right? So I know here it's at -1. So this is basically 0, 1, y is 1, and here this is at pi, -1, right? So the y values 1 and -1. So even just knowing this basic shape, that's a lot. That really can take you pretty far, farther than you might imagine. So you might say to yourself, that's good enough for me. I don't really need a lot of precision. So I'm gonna, since I know the asymptotes occur at negative pi over 2 and pi over 2, that's where I might start. And I might say, okay, I'm going to solve for where, when I'm given y equals -5 secant 2x minus pi over 3 plus 6, where is the asymptote? So I'm going to put 2x minus pi over 3 and solve it for negative pi over 2, and I get it negative pi over 12. So there's my first asymptote. And then I can say, well, you know, vertically, you got -5 and 6 here, so if you look back at your y values, you had 1 and -1. So when I don't even need to know what angle it's going to give me y equal 1, I'm going to put in some x value. I'm going to end up taking the secant of that angle, and it's going to give me 1. So -5 times 1 is -5 plus 6 is 1. And then if this is -1, I have -5 times -1 is a +5 plus 6 is 11. So it's, in essence, I'm going to get -5 times 1, we said was just 1, or -5 times -1 plus 6 is 11. So the y values are actually going, starting at 1 or 11, like this, opening up or down. And since this is reflected right here, that means I'm probably doing this, where I'm going to start here at 1 or something, and I don't even know what angle. It's just going to go something like this, and I know that that y value is 1. And then it's going to have some other asymptote here. I don't even know where, but I'm going to be here at some angle, and it's going to be 11. And that is really enough, probably, for you to be able to recognize which graph you should be choosing if you're just matching graphs, right? So the rest of this discussion, then, is really about, well, what if I need more precision and I don't get a graphing calculator to graph this? That's what this is about now. So I showed you the super quick and dirty how to just recognize it, right? But now I want to talk to you and just remind you that from the video 4 secant x plus 3, I told you I like to do certain anchor values, right? I use the asymptotes, the center value, and just a couple of anchor values that are nice, because these anchor values end up making it so that when you take the secant of that angle, you get nice whole numbers too, okay? Or -2, that kind of thing. So I'm going to do the same thing here, but this time, so I'm going to use the same anchor values, right? Here's my asymptotes, the center, and then the anchor values. And I'm setting this argument, the 2x minus pi over 3, and figuring out what will make it so that what angle will make it behave like the anchor values that I want. So what I mean by that is, for example, here, I set 2x minus pi over 3 equals 0, and I found that x equal to pi over 6 is what I'm looking for, so that when I plug in pi over 6 in here, let me show you that. When I plug in pi over 6 into that equation, I'll be evaluating the secant of 0, which is what I wanted because that's what I was solving for. The x value such that I'll end up having 0. So then I'll take the secant of 0, which I am familiar with. The secant of 0 is 1. Then I can evaluate it really easily because then I just go negative 5 times 1 is negative 5 plus 6 is 1. Boom. So then the point I'll actually plot is what I plugged in, x equal to pi over 6, and what I got out, y equal 1. Okay. Now, I did that with all my values here. So I found out that when I plugged in when I solved for what x would make this behave like negative pi over 3, I got x equals 0. So I know that its secant of negative pi over 3 is really 2. So negative 5 times 2 is negative 10, plus 6 is negative 4. So I plot the point 0 and then negative 4, and so on and so forth, right? So knowing these 5, shall we say, anchor values, so I got my asymptotes, the center value, and the 2, let's say, anchor values that I use to determine how wide or narrow the U's are. So this first one then gives me this. All right? So let's come and go back. Here's negative pi over 12 to 5 pi over 12. There's my asymptotes. And then my center value. Make sure I'm centered here. Yeah. Pi over 6 ends up being 1. And then 0 and pi over 3 end up at y equal to negative 4. So there you are. But now I got to get this other one, right? This is open down because this was reflected. Now I got to get the other one that's going to open up. So what I got to remember is, okay, what's the distance from here to here, from one asymptote to another? Well, because that's where the second U will fit going up. So I just said, okay, 5 pi over 12 minus a negative pi over 12 is basically pi over 2. So the next center point, if I had here pi over 6, I add pi over 2. That's the value I'm going to get. So when I did that, I get 2 pi over 3. And here's just a check. When I put in 2 pi over 3, I get that this behaves like negative 1, which is what I would expect, right? Because one opens up, one opens down, and it's reflected. So let's go back to the basic shape, sorry. All right, this one is going to act like the negative 1, so that's what I wanted. And so I get the y value is 11. Okay? So that means that when I put all this together, I plot the point 2 pi over 3, 11. So here's over 2 pi over 3 up 11. And then technically I would want to get these two, right? And I would say, you know, I'd go over a certain amount, and I know I'm going to go up. And go over a certain amount, I'm going to go up. And how can I tell what that would be? Well, it would be the distance between here 1 and this is negative 4. Sorry, I didn't have that on there. This is 0, negative 4. And this is pi over 3, negative 4. Right? So there's a difference of 5. So I'm going to go up 5 here. Right? And that's how I can tell. But this is, you know, the kind of precision you may be looking for. If you want it even more precise, you want to know where does that happen. You basically add pi over 2 to this x value, and then pi over 2 to this x value. And so when I add pi over 2 to 0, I'll be here, pi over 2. Then I'll go up 11 plus 5, right? So that was 16. And same thing here, pi over 3 plus pi over 2, and go up 16. So that's just, again, if you want a lot of precision. You may not even need these techniques. You certainly don't need them for this class, but you may need them later on. All right, thanks so much for listening.